Every time you open up a generative AI tool, I mean, whether you're asking for a quick summary, brainstorming, or, getting help with some complex technical problem, you're interacting with what is, well, arguably the biggest tech revolution in the last 50 years.
Hmm.
But here's the thing. There's this essential digital literacy lesson that a lot of people miss.
Mm.
Every single one of those interactions, whether it's with ChatGPT or Anthropic's Claude, Google's Gemini,
Right.
any of them, it falls into one of three distinct architectural categories.
And understanding which category you're in, proprietary, open, or truly open source, that's not just technical minutiae for engineers anymore. It really impacts everything.
And everything.
Yeah, from your fundamental data privacy, your company's bottom line to, well, to the very trajectory of global innovation. This is about being an informed participant in a technology that is, and there's no exaggeration here, reshaping the world around us.
Exactly. This is where we stop just using the tools and really start to understand the strategic choices behind them. Because those choices, they dictate who controls the data, who bears the risk, and frankly, where the next wave of innovation is even going to come from.
The whole AI landscape is just fundamentally defined by a series of trade-offs, isn't it? It's control versus customization, ultimate performance versus, ultimate privacy.
And centralized, multi-billion-dollar development versus this rapid, community-driven innovation.
Precisely. And there's no right answer in this mix. There are only strategic choices.
Okay, so let's unpack this. Our mission today, diving deep into the source material you brought, is to move past all the marketing language and really extract the key insights that define these differences. We want to thoroughly understand the distinct characteristics and, crucially, the practical trade-offs of proprietary, open, and open source AI models.
Right. And so what here is fundamental? If you're a consumer trying to decide which subscription aligns with your values, or an entrepreneur evaluating a long-term business model,
Or just trying to understand the economic and geopolitical forces at play.
yes, especially with things like national digital sovereignty, you need to know these foundational architectural differences inside and out. We're not here to declare a winner. As the sources show, these approaches just serve different purposes and reflect fundamentally different strategies for building, sharing, and, monetizing technology in the 21st century.
Right, to really make these concepts stick. Let's start with the basics. We can use some analogies that really capture the essence of each architecture. The first one, and it's the one we encounter the most, the one that dominates the public consciousness. That's the proprietary model. We can think of this as the locked box.
That analogy is spot on. It really emphasizes the lack of visibility and control. When we talk about proprietary models, we are primarily referring to, well, the major labs and tech giants, right?
Right.
OpenAI's foundational GPT series, Anthropic's Claude models, Google's powerful Gemini architecture. These are the frontrunners that are really defining the capability frontier at the moment.
So the core definition is that these models are developed by companies that keep the underlying tech private. It's a guarded trade secret. You, the end user, or even a developer integrating the tool, you never see or control the underlying code.
Never. Or the massive training data sets, or the precise model weights themselves. It is completely opaque, a total black box.
Your interaction is what's strictly limited to their interfaces?
Exactly. You might be typing into a chat window on their website, or maybe your custom app is communicating with their API, their application programming interface, which is, essentially a secure digital gateway.
But the critical element here is that the actual computing brain, the trained model itself,
Yeah.
it never leaves their infrastructure.
It stays locked down, running on hardware they own and manage in their own tightly controlled cloud environment.
And that leads directly to a really strong set of core characteristics, doesn't it? Because the company controls the environment completely, they also shoulder the entire operational burden.
They manage the continuous updates, the rigorous infrastructure maintenance, all the safety features, the alignment efforts, all of it.
So if a critical vulnerability is discovered, say a security exploit that could leak data, or a new ethical filter needs to be applied,
The proprietary provider handles it instantly, centrally, and globally, often without the user even noticing a change was made. This centralized management provides this tremendous stability and a very predictable user experience.
and that convenience, that predictability, that's what you're paying for.
That's the deal.
That's why usage involves subscription fees, like paying for ChatGPT Plus or pay-per-use pricing through those APIs. You're paying for a service, for access and reliability, not for the underlying software itself.
And then this is a big one for businesses. The company maintains the legal and technical responsibility for the model's immediate behavior and content filtering. That significantly reduces the regulatory burden on you, the end user, or the business.
Okay, so that's the locked box. Now let's contrast that with the other end of the spectrum, the purest expression of technology sharing, open source models. This is what we're calling the shared blueprint.
Yes. This architecture follows that deep-rooted philosophy of freely available software, but it's applied to this immensely complex world of large language models. The source material points to some key examples here.
And they're often backed by major players too, with a long-term strategic view, like Meta's Llama models or models like Falcon and that big collaborative research model, Bloom.
And when we say the entire model is public, we're emphasizing the complete transparency that's inherent in the model's licensing. This includes the model weights, which, to simplify for a moment, are basically the learned knowledge, the millions or billions of parameters that make up the AI's brain.
Okay, so the weights, the architecture details, even the training code itself.
All of it. It's all released publicly, usually under a highly permissive license, something like Apache 2.0.
And that transparency, that's the engine of innovation here, isn't it? It's what enables the next critical step. Modification, fine-tuning, and redistribution by anyone with the technical know-how.
Think about what that means in practice. A university research team in, say, South America, they don't need to ask Meta for permission. They can just take Llama, refine it specifically for chemistry research using their own local data sets, maybe translate it better for their specific dialect.
And then just redistribute that specialized model to local industry without paying a licensing fee or requesting clearance.
Exactly. And that leads directly to this phenomenon of rapid community-driven improvements and variations, which, we'll definitely get into this later, is a powerful strategic advantage for the company that released it.
But here's the crucial trade-off. With all that freedom and transparency comes full responsibility.
Full responsibility. The user who downloads and deploys that open source model takes full responsibility for its setup, its maintenance, its security, and critically, the consequences of its output. You own the model, so you own the risk and the upkeep.
Now, this is where it gets a bit nuanced and where the language can often trip people up. We have to talk about that middle ground, which the source material defines simply as open models. That's right. This isn't the locked box of proprietary, and it's not the fully transparent shared blueprint of open source. This middle ground, which we see with companies like Mistral AI, is a really effective hybrid approach. It's accessible, meaning you can run it yourself, but it's not completely transparent or unrestricted.
The key characteristic of open models is that the model weights are accessible for you to download. Now, this is a huge gain for control and privacy because you can bring the brain, the core knowledge of the AI, onto your own infrastructure.
That ability to self-host, that satisfies a massive demand from enterprises who are, really concerned about data sovereignty.
But, and this is the vital distinction that keeps it from being true open source, these models often maintain usage restrictions or specific licensing requirements. You might be allowed to use them for research or for commercial purposes only up to a certain revenue threshold.
Or you might have to agree to specific terms about acceptable use that are much stricter than a typical open source license.
Exactly. They offer the flexibility of self-hosting, while the original company retains some governance or strategic control over the model's use, particularly when it comes to commercialization. It allows the company to influence the market without necessarily giving away their competitive edge entirely.
So if we look at the whole spectrum, proprietary is about centralized control and a highly managed service. Open source is about freedom, complete transparency, and community innovation.
And open is that strategic mix. It gives you accessibility and self-hosting, but the original company keeps some governance over the business rules. That licensing nuance is absolutely crucial when you're assessing the strategic value and the risk profile of a model. The primary reason that proprietary models continue to dominate the news cycle and often hold the lead in capability, is tied directly to the astronomical cost and complexity of their initial development.
We absolutely need to linger on this. The colossal financial barrier to entry here. These numbers are often hard to get your head around, but they directly explain the strategic choices these companies make to lock down their models. The source material provides a really clear data point that it stuck out to me. Training GPT-4 reportedly cost over $100 million
In
in
that
computing resources alone.
That $100 million figure is a staggering floor. It's just the cost of raw computation, the electricity, and the specialized hardware usage during the training phase.
Just the training.
Just the training. Crucially, that figure explicitly excludes the immense researcher salaries, which can run into the hundreds of millions per year for a top team. It excludes the cost of building out the infrastructure, the massive logistical exercise of curating the data, and the years of preliminary foundational development that led up to that final training run. The true investment into a frontier model easily stretches into the high hundreds of millions, if not billions.
I think we need to go deeper into what that $100 million actually represents. In physical engineering terms. This isn't just a bunch of fancy desktop computers, right?
Should it all?
This figure details the necessity of running thousands of the most powerful, specialized GPUs simultaneously, nonstop, for a period that can last, what, 3 to 6 months? We're talking about units like NVIDIA H100s, these specialized chips that cost tens of thousands of dollars each.
And they're designed specifically for the intense parallel calculations that deep learning requires. You've hit on the critical bottleneck. It's not just buying the chips, it's building the whole infrastructure to support them. You need specialized networking fabric things like NVIDIA's InfiniBand, just to ensure those thousands of chips can communicate and share data instantly.
Because if the data transfer stalls for even a millisecond,
the entire massive months-long training run can be jeopardized, thrown out.
The logistics are just mind-boggling. The power demands are like a small town. We're talking dedicated power substations, industrial-scale cooling systems. The source material highlights that the electricity costs alone for a run like that can easily run into the millions of dollars.
The system is designed not just to process data, but to manage extreme heat and massive data flow across these intricate fiber optic cables at lightning speed. It is a global engineering feat that maybe, 5 companies in the world can currently afford to execute.
Right. And let's not forget the opportunity cost of it all. That $100 million is capital that can't be spent anywhere else.
Right. And when a company invests that kind of capital and risks it on a single research gamble, the strategic calculus behind keeping it proprietary becomes not just clear, but, mandatory for their survival. They have to protect that intellectual property.
That makes perfect sense. They have to ensure that they are the primary, if not the only, beneficiary of that massive upfront investment.
Exactly. And we can break down the drivers for companies like OpenAI, Anthropic, and Google into 3 main strategic pillars for keeping that lockbox approach. And they're all interconnected responses to that initial financial outlay.
The first pillar, and it's the one they cite most often in public, is safety and control.
This is critical, especially when you're dealing with the most advanced frontier models that have these advanced and potentially unforeseen emergent capabilities. Centralized control allows for rapid essential safety updates and rapid alignment efforts.
Okay, but doesn't relying solely on centralized control also create a massive single point of failure? I mean, if a proprietary team misses an alignment flaw, they unleash it on their entire user base instantly. A decentralized system might have localized failures, but not a global one. How do the sources weigh that risk?
That's a crucial counterpoint, and the sources show that proprietary companies address it by framing control as a necessary safeguard against malicious misuse. Because the model never leaves their custody, they can monitor all input and output, which is a powerful deterrent against large-scale coordinated misuse.
Like what? Generating highly personalized malware or...
For large amounts of sophisticated deepfakes. It allows them to apply specific guardrails and ethical guidelines across the entire user base instantaneously and, most importantly, prevent specific uses they deem harmful before they even start. With an open source model, if someone downloads the weights, they can just remove those safety features entirely.
Right. So proprietary control is less about preventing all flaws and more about managing the most serious, highest impact risks on a global scale.
Precisely. The second pillar is purely economic. Business sustainability. As we detailed, the development costs are massive and they're ongoing. They're in a continuous cycle of retraining and improving these models.
And that's where the subscription and API models become their lifeline. Subscription fees for premium access, pay-per-use API fees for developers. That's essential to support the continuous running costs.
The massive server clusters required to run the model for millions of users and to fund the continued frontier research needed for the next generation. These revenue streams aren't just profit, they are the necessary reinvestment fuel.
If they just release the model weights, that direct revenue stream would just what, dry up overnight?
Instantly. As users would just self-host and bypass the API entirely, the revenue from the locked box is what's necessary to fund the next $100 million training run.
Okay. And the third strategic driver is creating a competitive advantage. That capability difference we talked about, even a small edge, can become this unbreachable moat.
hmm When a proprietary model achieves capabilities far beyond its rivals, say, in handling highly complex multimodal tasks or maintaining long conversational contexts flawlessly, that superior performance immediately attracts the high-value, high-spending enterprise customers.
And enterprise customers, especially in like finance or aerospace,
Yeah.
they will pay a huge premium for guaranteed access to the absolute best performance, coupled with the security, the indemnification, all the dedicated support that comes with a major proprietary player.
So by keeping the core technology secret, these companies protect their current market share and ensure they are the primary and sole beneficiaries of the competitive edge created by their massive R&D investment. The proprietary approach is, at the end of the day, a rational, calculated response to overwhelming cost, driven by safety, financial necessity, and market dominance.
So we've established that proprietary development is this, well, almost necessary outcome
Mm,
of massive upfront investment. But this brings us back to the core strategic puzzle in the AI space. If the cost barrier is hundreds of millions of dollars, why on earth would a major tech giant like Meta spend billions on AI research, only to turn around and release powerful state-of-the-art models like Llama for free? Essentially for free. It seems to completely ignore the competitive logic we just detailed.
It does seem counterintuitive, but only if you view the product as the model itself. The strategic genius behind the open approach is that the product is actually the ecosystem built around the model. And the market share you gain by making your foundational technology the industry default. It's a long-term play. It's prioritizing platform dominance over immediate transactional income.
Okay, let's unpack that strategic reasoning. Let's start with what the sources identify as the primary driver, ecosystem development.
Think of this as a kind of intellectual subsidy. When Meta releases the Llama models under a highly permissive license, they are effectively seeding the market with high-quality free infrastructure. They're saying to the global community, here is the best non-proprietary tool, go build on it.
And what happens next is this massive decentralized explosion of creativity and engineering innovation on top of that foundational model.
Absolutely. Every developer, every researcher, every startup that takes Llama and creates a fine-tuned version or unique application or specialized tool, they're expanding the utility of Meta's core technology. This is work that Meta would never have the internal capacity nor the specific domain knowledge to complete on its own.
So in essence, they're leveraging the global collective talent pool. The source material clearly states that community contributions, whether it's finding specialized fine-tuning techniques or building efficient deployment wrappers or discovering new applications, can sometimes rival or even exceed internal corporate research efforts in scope and creativity.
It creates an incredibly powerful flywheel effect. Meta provides the engine, the community provides thousands of unique specialized vehicles, and Meta learns from the entire community's usage and innovation, feeding that vast collective knowledge back into the next, even more powerful version of Llama.
Which further entrenches their model as the standard.
Precisely, and this leads directly into the second strategic reason. Establishing industry standards. This is where that historical market precedent comes in. The really useful analogy to Google and Android.
That analogy holds up perfectly, doesn't it? Google didn't monetize Android by selling licenses.
No, they monetized the ecosystem it created. Specifically, by controlling the search and advertising pipeline that ran on every single Android device. By providing high-quality, open operating system alternative, Google successfully influenced how mobile development happened industry-wide.
They stopped Microsoft and others from cornering the market and shaped the entire structure.
And Meta is looking for the same kind of structural influence with Llama. They are positioning Llama to be the indispensable, non-proprietary operating system for the next generation of AI applications, especially for enterprises that value control.
So by providing the most competitive, high-quality, open alternative, Meta ensures that its architecture, its model structure, and its technical standards become the default for a huge, critical segment of the market.
The segment that either can't afford the proprietary API costs or strategically prioritizes customization and sovereignty. This move prevents any one proprietary competitor from achieving a total monopoly on the underlying architectural framework of the industry.
That's a clever move. It lets them influence the entire market without having to bear the operational cost of serving every single request like the proprietary providers do. They essentially outsource the serving burden to the community.
Exactly. And this positioning is strategically valuable because it keeps the market competitive and dynamic, which is beneficial for Meta's broader business interests, which span everything from social media infrastructure to hardware development.
Like their push into VRR, which will need highly customized, locally runnable AI.
Mm-hmm. And the third major strategic pillar here is research acceleration and transparency.
Okay.
Releasing these models openly is an enormous boon for global scientific knowledge. Open models allow researchers worldwide at universities, nonprofits, independent government labs to contribute directly to improvements in core capabilities, safety, and alignment. They are now empowered to peer under the hood and understand why the model behaves the way it does, not just what it does.
And without that level of transparency, the mechanisms of the most advanced AI are confined to just a few corporate labs, which creates a knowledge bottleneck.
It does. Openness enables a collective global understanding of how these complex systems function, allowing for faster development of collective defense, better alignment techniques, and ethical guardrails that benefit everyone, not just the company that built it. This approach reframes the investment in Llama not just as a business move, but as a critical contribution to the global scientific community.
So the strategic logic of openness is this sophisticated, long-game calculus. It's an investment in market infrastructure, community leverage, and shared knowledge, all aiming for platform dominance rather than just immediate transactional fees.
So now we shift from that strategic chess game played by trillion-dollar companies to the immediate practical reality for you, the listener. What does this architectural choice locked box versus shared blueprint actually mean for a startup's budget, an individual's privacy, or an organization's compliance needs?
This is where the decisions get tangible. The choice of architecture has immediate, measurable consequences on your cost structure, your data governance, and the internal expertise you need. This is where we connect the dots between the technical decisions and the balance sheet. Hashtag tag to meet you for individual users.
Let's start with the everyday user, someone who just wants powerful functionality. When you choose a proprietary model, you are fundamentally choosing proprietary convenience.
The benefits are immediate and clear, right? You get seamless, instant access through a web browser or a mobile app. There's zero setup required.
Zero. You get consistent, highly reliable performance that's backed by massive infrastructure, and you get automatic updates and improvements handled invisibly by the provider. It's truly the ultimate software-as-a-service model, designed for maximum accessibility.
But the trade-off is just as clear. The cost is recurring, usually $20 to $30 a month for premium access. And the critical factor for privacy is that your data passes through company servers.
Let's talk about that data transmission in depth. Your sensitive prompt, whether it's a proprietary business idea, a health query, or something deeply personal, it leaves your device. It travels across the internet, it's processed by their proprietary model in their cloud, and then the response comes back.
And even with all the assurances about data deletion, that data still exists, at least momentarily, on a third-party server.
Exactly. For casual use, like asking for historical facts, this probably doesn't matter. But for many professionals and researchers, that transmission path is a significant and often unacceptable data governance concern.
So let's contrast that with open source privacy. If you choose an open source model, you gain the ability to run the model entirely on your own device, or on a server you control completely.
This is the ultimate level of data sovereignty. Your prompts and the model's processing never leave your controlled network perimeter. This means complete, verifiable privacy. And you eliminate those recurring subscription or API fees after the initial setup. You get absolute control over updates and modifications.
However, let's be honest about the trade-offs, which is why this isn't the default for most people. It requires significant technical knowledge, or at least a high-quality, user-friendly wrapper application, to handle the installation, the configuration, and the proper maintenance.
And critically, the hardware barrier is substantial. Running even a modest 7 billion parameter open source model locally requires a dedicated, powerful GPU, often costing upwards of $500.
And if you want to run one of the truly powerful, top-tier open source models like Llama 3.2 at 70 billion parameters,
Okay.
you need specialized consumer-grade cards like an NVIDIA RTX 4090, which can cost over $1,800, plus all the necessary RAM and cooling.
That represents a large, non-trivial upfront investment, which is a very different financial profile than a $20 monthly fee. Hashtag tag BB. for developers and startups.
So for developers and startups, the decision shifts from personal convenience to strategic deployment. They're weighing speed to market, long-term scalability, cost structure, and future dependency risk.
If a startup chooses to rely on proprietary APIs, they are choosing the speed and scalability solution. They can integrate the API quickly, deployment is fast, and they can scale instantly without ever worrying about purchasing, provisioning, or maintaining physical hardware.
Scalability is the massive benefit here. If their app suddenly goes viral, growing from 1,000 users to 1 million users overnight.
The proprietary provider's multi-billion-dollar infrastructure just handles the entire load. The startup doesn't have to write a single line of scaling code. They just pay based on usage, the amount of tokens they input and output, typically starting around 1 to 3 cents per thousand tokens for advanced models. It's a pay-per-use, variable cost structure. It's OpEx.
Let's use the practical example from the source material. Imagine a new e-commerce chatbot designed for highly personalized customer service. If this bot handles 1 million conversations monthly, relying on a proprietary API might cost them between, $500 to $2,000 in API fees per month.
Right. And the beauty of this model is that the upfront infrastructure investment is minimal. It's just engineering time to connect the API.
This low barrier to entry and variable cost structure is a lifeline for small teams and pre-seed startups. But let's inject some friction here. They face severe vendor lock-in. Their entire business is dependent on the provider's continued service.
And more importantly, the provider's terms of service and pricing structure. That's the strategic vulnerability. If the proprietary company decides to raise the price per token by 50% or worse, decides the startup's use case violates a new term of service, the startup is completely paralyzed.
They have to either absorb the cost immediately, which could destroy their profit margin, or face the painful, expensive process of rapidly re-engineering their whole product to switch models.
That lack of control over a core component of your business is a massive long-term risk.
Okay, so on the flip side, we have open source deployment, which represents the control and customization solution. The startup decides to download the weights, put them on their own cloud servers, AWS, Azure, GCP, or run them on their own on-premise hardware and deploy the model themselves.
They gain absolute control over their technology stack. They can customize the model extensively for highly specific needs, maybe optimizing it for their internal data structure, or integrating it directly into an existing proprietary database, or teaching it industry-specific jargon. Their only recurring cost is the raw compute cost.
So let's revisit the cost contrast using that same 1 million conversation scenario. That same chatbot might require, $300 to $800 a month in server costs to run the equivalent open source model efficiently. The monthly operational savings are clear.
They are, but that lower operational cost, the OpEx, it comes with significant overhead and a massive shift in capital structure to CapEx. The company has to make an upfront infrastructure investment, whether that's buying physical servers or setting up robust, scalable cloud infrastructure and paying for dedicated virtual machine instances.
And more importantly, they are trading API costs for internal expertise. They need a dedicated team of machine learning engineers and DevOps specialists for setup, continuous security patching, monitoring, and managing updates. The engineering hours required to babysit a self-hosted model are a huge hidden cost that many startups underestimate. ####C.
For organizations.
Finally, let's analyze large organizations. This is where the sheer volume of data and the presence of legal and regulatory compliance increase the stakes exponentially.
For large organizations choosing the proprietary enterprise route, they're really buying a high degree of managed risk, reliability, and external accountability. They benefit from highly formalized enterprise agreements, indemnification clauses, and dedicated support teams. They rely heavily on the vendor managing all the security updates, which reduces their internal burden and regulatory exposure. Plus, many proprietary providers now invest heavily in obtaining built-in compliance certifications, SOC2, HIPAA readiness, things like that, which is essential for regulated industries.
But the key concern, the anchor around the proprietary neck for large organizations, it's still data governance, isn't it?
It is. Even with top-tier enterprise agreements, the organization has to be fundamentally comfortable with the knowledge that their proprietary, highly sensitive, or legally protected data is being transmitted to and processed on a third-party server outside of their direct control.
Conversely, open source enterprise is attractive precisely because it completely solves that data governance problem. The primary benefit is complete data sovereignty.
Right. Since the model weights are downloaded and run entirely on the organization's own network behind their firewalls, on their private cloud-sensitive data never leaves their perimeter.
This is an absolute necessity for highly regulated sectors, particularly healthcare systems handling patient records or financial institutions handling proprietary trading data. It also allows for unparalleled customization.
hmm Think about the practical difference. They can train an AI on their 50 years of internal proprietary legal documents, creating an AI that understands legal jargon unique to their jurisdiction, or a model trained on highly localized medical imaging data. That level of targeted performance and privacy just can't be achieved with a proprietary generalist model.
And we can't overlook the ultimate strategic advantage: no vendor lock-in. If the organization is unhappy with the performance of one open source model, they can swap it out for another, or they can maintain and fine-tune their existing model indefinitely.
They're not dependent on a single company's continued existence or favorable pricing. The barrier, however, is substantial. It requires significant, permanent internal investment in a dedicated team of ML engineers and DevOps specialists to manage and maintain such a critical piece of infrastructure.
Okay, now that we've thoroughly established the strategic, the financial, and the privacy trade-offs, we have to address the capability question head-on. For all these differences in architecture and business models, how do the models actually stack up when it comes to raw performance and the future direction of the industry?
This section really provides a high-level analysis of the current landscape, based on standardized benchmarks as of late 2024. The consensus has historically been that proprietary models lead, and they do. But the critical insight is that the gap is narrowing faster than anyone anticipated.
The proprietary leaders, GPT-4, Claude Opus 4, and Gemini Ultra, they still universally achieve the highest scores on the most complex reasoning tasks. This is where that sheer, uncompromising compute investment of over $100 million really pays off.
They excel at highly nuanced understanding, following extremely complex multi-step instructions that require that chain-of-thought reasoning. They exhibit the strongest multilingual capabilities because of their enormous and meticulously curated training datasets.
And because of the centralized control, these are the models that receive the most sophisticated, resource-intensive safety training and alignment efforts before they're released.
But the narrative is rapidly shifting away from just proprietary dominance toward open source maturity. The top open source models, like Llama 3.2 and the latest iterations of Mixtral and Falcon, they perform highly competitively on a massive range of tasks. The key insight here is the velocity of innovation. The open source community is just iterating incredibly fast.
And the source material puts a concrete, measurable number on this trajectory that should be a huge aha moment for you. Open source models typically trail the frontier proprietary models by only 6 to 12 months in capabilities.
Wow. And while that gap exists, it's really only relevant at the extreme edge of complexity think models, writing PhD-level research papers or solving advanced multi-domain physics problems.
Right.
For many real-world practical applications, which is probably 80% of what organizations and individuals need, like summarizing meeting notes, drafting standard emails, generating simple code snippets, the current state of the art in open source is entirely sufficient, highly cost-effective, and critically offers those privacy advantages.
This brings us to that crucial difference between specialization versus generalization, which often determines the architectural choice for a specific project.
Proprietary models generally optimize for broad generalization across diverse tasks. They are built to be the best possible Swiss Army knife, great at everything for everybody, without requiring customization.
But open source models excel precisely because of their flexibility to be fine-tuned for specific domains. This is where they leverage that transparency and permissive licensing, and this is where they often leapfrog the generalists.
Consider the examples we saw. A medical AI assistant fine-tuned using specialized proprietary training data on, say, rare neurological disorders. By focusing all its knowledge on that niche, the open source model becomes an expert specifically in diagnostics for that limited field. It can provide more accurate, targeted results than a general-purpose proprietary model.
Or legal document analysis customized for specific jurisdictional language, which a general model might struggle with. The transparency of the open source blueprint lets domain experts inject high-value, specific knowledge directly into the model's weights.
And that level of targeted performance often surpasses the proprietary generalist precisely because it sacrifices breadth for extreme depth. Moving beyond performance, we have to acknowledge that these architectural choices are fundamentally shaping accessibility and global power structures.
Absolutely. The tension between the two approaches is driving accessibility and democratization, but in two distinct ways. Open source enables AI access in regions and contexts where proprietary API costs are simply prohibitive.
Right. Universities, developing nations, small nonprofits, they can now experiment and innovate without those significant financial barriers.
But the proprietary model plays an equally important role in expanding access by offering incredible ease of use. This immediately brings powerful AI capabilities to non-technical users who don't have the expertise to set up their own servers or the budget for a high-end GPU.
So both models are democratizing AI just for different user groups defined by their technical capability and financial resources.
And the discussion around privacy and data sovereignty will increasingly become the decisive factor for large-scale enterprise and government adoptions moving forward. We have to reiterate this critical choice.
Open source models can run entirely offline, keeping sensitive data localized, auditable, and secure. Proprietary services offer convenience but mandate data transmission to a third party. And as the source notes, different industry contexts demand radically different approaches.
A healthcare system handling patient records will almost certainly choose open source on-premise. Meanwhile, a quick market research firm might safely stick to proprietary APIs for speed and cost efficiency.
And finally, we see the global perspectives. The choice between these architectures is rapidly moving beyond just a business decision and becoming a matter of national interest.
The documents we reviewed highlight, for example, that Europe is explicitly investing heavily in open models for digital sovereignty.
And this isn't just about privacy, it's the concept that they should control the core technologies their digital infrastructure relies on, rather than being dependent on vendors from other geopolitical regions whose legal frameworks and foreign policies might shift unpredictably.
The fact that no single approach dominates globally really highlights the diversity and health of the current ecosystem. It's a technological arms race being fought on two fronts simultaneously, isn't it?
It is. The proprietary giants pushing the frontiers of capability with massive resources, and the open source community rapidly closing the gap, ensuring customization, sovereignty, and platform competition remain paramount. It's a system designed for maximum structural pressure.
We've covered extensive ground today, moving from the staggering financial logistics of training a frontier model to the strategic reasons Meta would effectively subsidize global AI research by just giving away its models.
So what does this all mean for you, the learner? I think the final decision matrix is clear. There is absolutely no single right answer. There are only trade-offs.
The choice depends entirely on your specific context.
Yeah.
You have to rigorously evaluate your privacy requirements, your internal technical capability. Do you have the engineering team? Your budget structure. Do you prefer a fixed capital expenditure or variable operational expenses?
And the required level of customization needed for your specific task. Choosing the wrong architecture for the wrong context can introduce massive unnecessary risks, financial drain, or even regulatory noncompliance.
And we should reiterate the importance of this digital literacy. Understanding these trade-offs allows you to move from simply being a passive user of AI to making informed, strategic decisions about tools that are increasingly central to how we all work, learn, and create.
Knowing the architectural difference between a locked box and a shared blueprint fundamentally changes how you assess risk and value in the modern technological landscape.
And if we connect this to the bigger picture, the sheer diversity of the current ecosystem, where multiple approaches are competing and evolving at the same time, that might actually be the strongest driver of progress we have right now.
I think so. The existence of open source models keeps the proprietary giants honest, forcing them to innovate faster and price more competitively. Conversely, the proprietary labs push the high-cost, high-risk frontiers that the open source community can then later adopt, refine, and democratize.
This balance of control and openness prevents a technological monopoly, ensures broad accessibility for different user profiles, and drives necessary innovation across every possible vector simultaneously.
It's a beautifully complex system, and staying informed helps you navigate this dynamic landscape effectively. We encourage you to consider your own relationship with these different architectures and how they align with your needs and your values as these technologies continue to mature.